A lot of the research we do focuses on trying to distinguish natural versus anthropogenic aerosols. Natural aerosols are there independently of humans. So for example, things like forest fires or things like dust from the deserts or sea salt from the ocean are there and were there before humans. And just due to natural processes, like for example, wind picking up the dust from the desert and putting it in the air, and that's there whether we are there or not. Anthropogenic aerosols or man-made aerosols are particles which are there because of our activities. So for example, we may build a power plant, and in the power plant we burn coal, and then as we burn that coal, we produce some particles and we put them in the air through the chimney. So this is the plume that you see when you fly through some of these plants. Or another example, maybe closer to home, is looking at cars and trucks. So when every car and every truck produces some particles, but you can see, for example, a smoky truck or a smoky car, and you see that black plume of smoke. That black material, those are aerosols. And then once you put them in the air, they actually stay in the air for a couple of weeks, and that's why we care about them. They're gonna fly in the atmosphere for a long time, and they're gonna mingle with the natural aerosols. So the question of the distinction between natural and man-made or anthropogenic aerosols is really where a lot of our research goes around. I mean, and that is not an easy question, but really what we try to do is to look at the chemical composition. And much like people have their own fingerprint, different sources of pollution have different chemical fingerprints. And the instrumentation we use, that we will talk about later, really its strength is that it can tell us the amount of aerosol, but it can also give us the chemical fingerprint in a very precise way. And what we've been able to do in the last decade is to be able to see some of those fingerprints from each other. So if we fly through a volcano, or we fly through a forest fire, or we fly over a polluted location, the fingerprints look different. So then you go to a place, in the middle of the ocean or in a mountain where you may be away from all the sources, but those fingerprints still stay to some degree, and then you are able to tell what sources are affecting the concentration of this pollution all over the planet. And that's really the core of what we do, is trying to get a better handle on the fingerprints and try to identify them in the ambient air.